Welcome to video 3 in a series of introductory videos for SolidCAM. This video's topic is creating a new CAM part, specifically for the milling module. So what we're looking at now is the SolidWorks part. So you definitely want to bring in your SolidWorks part. This could be a translated part from a different format, or this could be a native SolidWorks part. In either case, as long as it's SolidWorks geometry, we can work off of that. So we'll start by opening up the part, and then we'll go to Tools, SolidCAM, New, and since we're covering milling, we'll go to milling. Later on in this series of introductory videos, we'll see how to do turning and mill turn. The first window from SolidCAM is asking us what type of CAM part file we want to create, either external or internal. Internal means that we're adding all our tool paths, our tool definitions, anything we're adding for the programming side, we're adding it to a folder inside of the feature tree of the overall SolidWorks part. So that means that we're basically putting it internally into the SolidWorks part. It's one part file that you're working with. This is beneficial for file management purposes. You can check this in and out of a Vault or a PDM system. You can put this on your network and share it with other people that need to see the SolidCAM part. The drawback is that it is still in the same file. So that SolidWorks part will be increased in size because it now has all the SolidCAM stuff behind it. And anyone who doesn't have SolidCAM will still be able to open up the SolidWorks aspect of that file, but they'll have to load this massive file that has all the SolidCAM stuff as well, even though they can't even see it. Now, how that's done is basically the folder would just take the name of the SolidWorks part file and call it _milling, and then you would just see it as a folder in that internal. If you go with external, this is a separate SolidCAM only file. This is a file that has the same sort of stuff we're looking at in both versions of the file, except that it's a separate file and it acts as an assembly. So that means that you can bring in other solids to represent vices, clamps, custom stock, anything extra that you want to add in there to better program your part. And because it's external, it allows the programmer to do whatever it needs to do to that part without the design side seeing it. Meaning that if you add sketches or anything like that to get your part better programmed, the original design model, being a separate file, does not see those updates, doesn't see any of those stocks or anything like that. Now, on the opposite side, if a change is made to the original design model, your external SolidCAM file will be associative to that and will update the model itself. So it will keep track of the solid model from SolidWorks, keeping it up to date, but whatever you do on the program side doesn't go backwards. It's a one-way associativity. So if you go with external, it's going to, by default, take the name of the original SolidWorks file, but you can change that name if you like. You can always overwrite that name. What I normally do is myself, I just put in a little bit something extra there just so I know. As an external file, I can tell it where I'd like to save that file. So referring back to video 1, in the user directory section, we told it where we'd like it to save all our files. That's this address right here, or I can browse to a file, folder location on my network or on my hard drive, anywhere else I'd like to save it. Or additionally, because it is external file, we could just check this box and actually get the SolidCAM file to be saved side by side with the original SolidWorks model. And if you have that box checked by default, it'll always just save it side by side with the original model. So again, depending on your file management requirements, you have that option there. And then also referring back to video 1, the units of measure used for this particular CAM part file are decided here, metric versus inch. What external allows you to do is program in units that are different from the original design model. If we had stuck with SolidCAM internal, we would be using the units of measure from that SolidWorks file. So if the original design model was in metric, you would have to program in metric. If you're in external, you have the option here of choosing what units you want to work in. So if the original model was in metric, but I need to program in inch, I'm programming an inch just by clicking it on here. We're going to go with external here because it has the more options. If I click on the green check mark, what it'll do is it'll close the original SolidWorks model and open up a copy of it inside the SolidCAM external. That copy is labeled design model. And if we take a look at the feature tree, first you'll automatically see that the SolidWorks external acts as an assembly file. So again, we can bring in solids that represent vices and clamps. Design model is the original part file, just copied into SolidCAM external. Anything that falls under that heading of design model is associative back to the original part. So because of that, and because that can get overwritten if there's a revision change, what you'll want to do is place any sketches that you want to remain all the time under CAM. This cam solid is added, it's empty, but it's added so that you can add sketches or anything like that you want to do to the part without worrying about associativity. So next is the post-processor. So post-processor list will show all the posts you have available to you, either from the trial copy of SolidCAM that you first installed, or any posts that were purchased by your company and added to your GPP tool folder. They will appear there. The post controls what you can do inside the CAM part file. So right now I'm choosing a 3-axis post. I'll only have access to 2.5D and 3D toolpaths. But if I had chosen a 4th axis post or a 5-axis post, we would see those toolpaths open up as well. Coordinate system. The coordinate system is essentially the offset on the machine. So if your machine uses G54 or E1 or P1, whatever it is in the G code, it's the first offset on the machine. In the software, we just call that MAC1. MAC1 is the first offset, MAC2 is the second offset, and so forth. The position number is just angles off of that. So if we were doing a 4th or 5th axis part, we might have some indexed angles where we're going to look at this thing at different angles and machine it at different angles. The position number just relates to that. So MAC1 position 2, MAC1 position 3, those are just angles off of MAC1 position 1. Those are just angles for 4th and 5th axis. You set up your coordinate system using one of these 5 options. The 5 options, you choose whichever one best fits the geometry that you have available to you. So we'll start from the bottom. By 3 points associative, if I have a design file that only has points, let's say it's a point cloud, or maybe it's a translated DWG file and there's no straight edges, or maybe it is a solid that has only curved surfaces. There are no straight edges to it, no flat faces, and all I have is endpoints. I can use the by 3 points associative to define an origin. So let me just choose this point right here as my origin. I choose a point in the X direction, so I get X axis positive, and then a point in the Y direction to get the Y axis positive. As soon as I have X and Y, I have Z. If I have a translated DWG or DXF file, maybe it's just 2D geometry and I have some lines I can use define. I can go and choose an origin once again. I can choose a line in the X direction. I can choose a line in the Y direction. Once I choose those, X and Y, I get Z. The other option's a little more specialized. Select coordinate system is if I had a coordinate system from SolidWorks that I brought with the design model. This could be maybe center of gravity. This could be a touch-off point that was designed for setup by the designer, by some sort of organizer, and then it brings in here in terms of SolidWorks. This is simply just copying whatever coordinate system you already had pre-existing from SolidWorks into SolidCAM. Normal to current view is more for 4th and 5th axis, where we don't really know what angle we want to put it at, but by rotating the part around, we can kind of eyeball it and get an idea as to what angle we want to put this at. This is more for setting up those indexed coordinate systems, because this will set up a good angle for the Z-axis coming out of the screen, your X-axis going to the right of the screen, and your Y-axis going to the top of the screen. This is simply just a perpendicular view of the part, but this will use the origin set up under MAC1 position 1. So this is best used for subpositions, MAC1 position 2, MAC1 position 3, and so forth. We'll end off with select face. This is the one that's most used because it's best used for solid faces like this one. We have some nice flat faces here. We can orient our Z-axis to those faces. And the reason we need to orient the Z-axis in any case is because the Z-axis acts as our tool axis. This is the direction we want the tool to come from. So if I want to machine this pocket, these holes, I'll need a coordinate system that is perpendicular to that face. So with select face turned on, I can click on that face and add my coordinate system. Where it places the origin of that coordinate system is controlled down here. So in this pull-down menu, again, we've got 6 options there. All you're really doing here is choosing where you'd like to start your coordinate system. Once you place it on screen, it's not stuck. You can move it around using some of the other options in this window. But just to place it right off the first click, we can decide that using one of these options here. So let's say we say top corner of model box. The model box is just the outside edges of this part. So you can see here that edge right there, that line is flush. That edge right there, or that face right there, that edge is flush and that line is flush. And then that line and those points indicate that corner that this thing would make. and it placed it in the top corner of that model box. Now, I don't want it to be there. I wanted it to be over here. So using the options on the left side, I can say pick origin. I'll click on that point, and then my X and the Y are in the wrong direction. I'll just flip those around the Z-axis and get them in the right direction. You'll notice that the model box also has points at the center of each edge and the center of each face. That is, again, to help you to place your origin in case you didn't want to put it in wherever it immediately placed it. In addition to that, if we just scroll down a little further here, we have modify by delta and modify by rotation. So we can actually move this around the part wherever we want it to be relative to the part. And that is the operative thing here. We're setting up an offset on the part rather than by the space. So you click on the part, you say how far away from the part you want to go, or you choose the top face of the part to set your Z equals 0. You have control over where this thing is being placed. Another thing to note is the SolidCAM coordinate system is separate and actually in a different angle than the SolidWorks coordinate system you see in the bottom left corner of the screen. That is, again, by design. The design model could be designed as part of an assembly. It could be however it's designed based off of the geometries available inside SolidWorks. Once you come into SolidCAM, you're placing this all relative to the part. This is how it's going to sit on the machine, how you're going to set it up on the machine. You do the same sort of thing here. You're touching off on the part. So once I confirm where my coordinate system is, I'll just click on the green check mark to create it. This window right here is just showing us our levels. So part upper level is Z equals 0, because when I clicked on that face, I set it as Z equals 0. And then as we saw from video 1, my clearance level, my tool start level, and my tool Z level, those values were defaulted by the global settings. And they came in here and just inserted those there. Click the green check mark to go back to the main window. And it just shows us our macro in position 1. If I want to do some programming on the back side, I can do it here, I can add the coordinate system here, or I can do it later. You always have the ability to come back to these windows and add things that you forgot to add. But I'll just do it now just to show you how the coordinate system works. So in the same part file, I'm going to program for Mac 2. That'll be my G55, that'll be my E1, my E2, my P2, whatever it is you're looking for. This is the second side of the part. On the machine, I'm taking it out, flipping it around, putting it back in my vise. Inside the software, I'm just giving it a new coordinate system. So let's say we use top corner model box once again. I'll click on that face, and that allows me to put a coordinate system there with the Z pointing in that direction, indicating that I now have the ability to add a set of operations for the backside, all in one file. We don't actually have to create new files for new setups. So I'll click the green check mark to accept those coordinate systems. And now next we go to stock. Stock is the raw material you're going to make this part out of. So again, many options under this heading right here: box, extruded boundary, 3D model, cylinder, and STL. We'll start from the bottom. So STL is a file format that's common between different CAD softwares, different CAM softwares, and basically what we use it for is internally. If you are programming for one machine, let's say you're programming on a lathe, you've turned the part on the lathe, and you want to save that turned stock and use it in another SolidCAM file. STL allows you to do that. So if you've programmed between different files and you want to share the geometries of that machine stock, this is the way to do it. You come here to Define by STL, and you browse to that STL file, and you locate them. There is a tips and tricks video on our YouTube channel regarding this exact use. So I would refer you to that for the STL use. Cylinder is more for turning. So we're not going to use it here. We'll see this when we get to the video for creating stock in turning. 3D model allows you to choose another model on the screen. So if I had imported another custom stock, or for my previous example, that turn stock, if I placed it on here and mated it to my part using the SolidWorks mating functions, I now have a 3D model that's properly sitting with my target. I can click on it and assign that as my stock. This is a good way to remachine parts that have already been previously machined. This is a good way to use oddball stock. You design it inside SolidWorks and you bring it in here. Now, in the case that you have some very basic stock, you have these other two options here. Extruded Boundary allows me to choose a profile from our part. Let's say I choose this top edge right here. That gets extruded through the Z-axis. So if we take a look at what that's going to look like, that took that profile and extruded it to the top and the bottom of that part. This is good for when I'm machining actual extruded parts, extrusion stock. But lastly is box, the most commonly used stock definition inside SolidCAM. And all it's going to do is place a box around the part. We have three options to do that. So let's start with relative to model. Relative to model is going to place a box around my part. And I've added just these default values here, about 80 thou on each face, and then 240 on the bottom face there, just assuming that's where it's being held in the vise. This is just a quick way to get a piece of stock on my part. So I have something to machine. And I can modify this. These are incremental values from the outside of the part. So let's say I wanted to put 100 thou, 100 thou. You can see that on each one of these edges, it's actually expanding. And on the bottom, let's just put 500 just to really show that off. So you can see there, it's just putting it around the part. This is incremental from those faces. If I want to add absolute coordinates, I can click on absolute. And right now, it's putting a 4x4 cube centered on my coordinate system. So what I could do is I can actually modify this value here as well. So let's say we put x positive is 5, x negative is just -1, y positive is 5, y negative is -1. Put that at, let's just say 100 thou, and then we'll leave that at 2. So you can see that it starts to place a box using those coordinate systems. Each one of those points, each one of those edges is using this absolute coordinate system to place it. Now, if your coordinate system was placed at the top corner of the stock, or your coordinate system was somehow placed that you can use these absolute values very nicely, then it makes sense to use that. But this can be kind of tedious because you have to try and figure out how to place the stock in there. So there's the third option. In the third option, I can click on the solid, I can place a box around there, but I have the ability to tell it how big that box should be, and then how to center or offset the box from the part. So let's do that real quick. Let's take this box and we'll make it a 6 by 6 by 1.5 piece of stock. So that is the size of that green cube there. It's basically using the values, the measurements of that stock. And now when I go down to the second section, I can look at the offsets. So the offset is defaulted to center. If we look at this from the top view, it's centered in the X and the Y direction. If we look at it from the side view, it's centered in the Z direction. So what I want to do is I want to make sure that it's centered on the X and the Y, which makes sense. But for the Z direction, I just want the top face to have 10 thou. Because I'm just going to machine or face that top 10 thou off, and then the rest of it, I just want it to be on the bottom edge of the part. So you can see there that it's offsetted. So that is still 1.5 inches, but it's 10 thou from the top face there. In either definition, if you want this green sketch to remain behind so that you can use it for some of your toolpaths later on, you can click on Add Box to CAD Model, and it changes that green sketch to a permanent one. Click on the green check mark, and we have our stock definition. Next is the target definition. Now, target is pretty simple. It's just the representation of the final part. After all your toolpaths, what do you want the part to look like? What do you want to turn the stock into at the end of your operations? So that's usually just the part you brought in, your design model. Just click on it, click the green check mark, and that's it. That's all you need to do to define your target. Typically, you can add your stock and your target for things like simulation purposes, for your 3D toolpaths. You definitely need them. But at minimum, you just need to add your post and your coordinate system. Once you've added a post and coordinate system, you can just click the green check mark to accept all this and get going. You don't necessarily have to add the stock and the target. But it's a good idea to do that because then you can take advantage of all our simulations. So I'm just going to click the green check mark to accept this. So now we're in the part and we can add toolpaths, but there's one last thing that we want to check just to make sure that we have everything set up. You'll notice in my left menu, I have something called setup. Now in video 1, I talked about this briefly. I set it up so that it added the machine setup for me. Now, if it doesn't do that for you, you can always go and say machine setup and then put it at the start of the tree. You want to add a machine setup every time you change the Mac position. If you're going to do a different offset, do operations under a different offset, you need to add the machine setup. And the machine setup is pretty simple. We take a look at this window. All we're doing is we're telling it what fixtures we want to use and what coordinate system we're working under. So I'm going to tell it that we're using Mac 1 position 1 in this particular coordinate system. If I click on this green icon here, I can take a look at how that sits in space. If I had anything that represented my table or my machine, I could see that that I need to put my part on the table. If you look here, there's the overlapping coordinate systems. If we take a look at this from, let's say, the side view, and I'll just put my mouse in here. If I wheel this up on my mouse, you can see there's two coordinate systems. The one on the bottom represents the table. That's your machine 0. That's the 0 face of the table. Mac 1 position 1 is that second coordinate system. I'm basically just telling it how it sits on the table. Now, if I brought in a solid that represented my vise and my clamps, I could set this up so that it looks as it's going to look on the machine. I can see how the vise sits on the table, how the part and the stock sits inside the vise. I can have this whole thing modeled. So the purpose of this is just so that you can actually check for limits and collisions and that sort of thing as well. At minimum, what you want to do is just make sure that you have this set to Mac 1 position 1. And if you don't have a table representation, you can leave this at 0. But to understand what this window is, you can always click on the green icon and see what's going on here. Under table is where you can actually select your fixtures. So again, if I had a solid on screen that represented my vise and my clamps, I can always click on here, go to these 3 dots, and select any solids on screen to represent my vise and my clamps. This works the same way as when you define your target. All you're doing is just clicking on the solid and telling SolidCAM this particular solid acts as my fixture. When I go to do operations on Mac 2, I'll need a machine set up for Mac 2. So I'm just going to right-click on the last thing in that window. Right-click on the operations, and we'll go machine setup, and I'll put one at the end of the tree. And then this one will be setup -1. And for that one, we're going to work under Mac 2 position 1. So I'll just tell it that that's what we're doing. And that's it. So I can put my side 1 operations under the first setup. I can put my side 2 operations under this setup. And you can label them as well. So if you don't want to confuse yourself, you can always say side 2 and side 1. And I do that just by highlighting it and hit F2 on my keyboard, and you can relabel that. Any questions on this or anything else from SolidCAM, just give us a call at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com. And stay tuned for the rest of the videos in this YouTube channel and this video series. Thanks for watching.